Hey guys, welcome to week 6 of Algebra 2. We're going to go over polynomials this week. There's a lot of material, so stay with me. Remember, we've done this before, so it's a bunch of review, so I'm going to go through a lot. The first thing we did with polynomials, we talked about rewriting them in standard form. Remember, that means we put our terms in order from the highest degree to the smallest degree, which is our exponent here. So in the example, this is not in standard form because the x to the power of 4 has the highest exponent. That comes first. Then a power of 3, power of 2, power of 1, and no exponent at all. Also in this standard form, we recognize the very first term is special. It is called the leading term. This leading term is going to help us when we talk about turns in our graph, when we talk about end behavior in our graph. We're going to refer to our leading term often. So it has our leading coefficient, which is the first coefficient. In this case, it would be a -1. It also has the degree of the entire polynomial, which is a 4. Okay, we're going to get more into that. We can name the polynomial by that degree. So whatever the highest degree is, we can classify the entire polynomial by that piece of information. So if our degree is 0, meaning there is no degree, there is no variable. So like, let's say if I had 5, okay, that's an example of a constant. It's just a number. To graph y equals 5 would be a horizontal line, so there would be no turns. Okay. Next, if my degree is 1, so an example of that would be like, let's say 3x plus 2. Okay. This has a degree of 1. This exponent x here has an exponent of 1. That's called linear. Okay, because it's a line. And again, there's no turns in a line. If my degree is 2, we call it a quadratic. An example of this would be like 4x squared minus 5x plus 7. Our highest exponent here is a 2. That's the degree of the whole term. If I were to graph a quadratic, it only has 1 turn. All right, a cubic function is a polynomial with the degree of 3. That would be something like, already used 4. Let's say 2x cubed minus, I don't know, 3. That would be a cubic function because my highest degree is 3. And cubic functions have 2 terms. They look something like this. Quartic is a degree of 4. So like x to the 4th, let's say negative x to the 4th plus 2x squared minus 1. That would be a degree of 4 because 4 is our highest exponent. It actually has 3 terms. It looks something like this. Finally, a quintic has a degree of 5. So let's say we had negative 3x to the 5th plus x squared minus 5. Okay, that has a degree of 5 because 5 is our highest exponent. This has 4 turns, so it would be something like this, where it has 4 different turns in it. All right. We can also name a polynomial by how many pieces there are or how many terms, okay? So terms are pieces. What separates the pieces is a plus or a minus sign. So if we only have 1 term, it's called a monomial. It is just 1 piece, and it could be like 5xy, okay? That is just 1 piece. There's no plus or minuses. It's a monomial. Having 2 pieces, having 2 terms is a binomial, means there's a plus or minus that separates them. So if I have, I don't know why I like that. There we go. If I have x squared and then minus 6x, that's a binomial. It's 2 pieces. Trinomial is 3 pieces. So let's say I have 7 plus xy minus 3y. That is 3 different pieces. A polynomial has 4 or more, so we don't really give a special name for anything with 4 or more pieces. So that could be something like, say, like x cubed y squared minus z plus 7, I don't know, plus 12. Okay, anything with 4 or more pieces, we're just going to call a polynomial. Okay. Here we have end behavior. Remember, I told you back here that this leading term is going to help us with lots of information. This is the only piece you need to determine end behavior. Okay, looking at your leading term, I need to know, is my a value going to be positive or negative? So that's my leading coefficient right here. Okay. Is our leading coefficient positive or negative? And then you need to know, is your degree going to be even or odd? Okay, so if my leading coefficient is positive and my degree is even, like in this example, my leading coefficient is 4, my degree is 4. So I have a positive leading coefficient and an even number for a degree. Both of my ends will be going up. So they're both going up to positive infinity. You see they both go up forever. So their end behavior is going to be up and up. All right. Second example here, my leading coefficient is still a positive number. It's positive 2, but now my exponent is a 3, which is an odd number. So because of that, it's going to start down at negative infinity, and it will end in the positive direction. So our end behavior is down and up. I like to tell my kids odd is for opposite, okay? So they're going to go in opposite directions if your degree is an odd number. And the positive leading coefficient shows you where it's going to end. So it ends up being in the positive direction. The other side was opposite. So down, then up. Okay, and it does matter which one you say first. All right, if my a is negative, so here, see, I have a negative leading coefficient, negative x squared, and a positive degree, okay? Negative means they're both going to be going down this time. See how they're both going down to negative infinity? So that's down and down. Notice when your degree is an even number, your ends are matching. They're either both up or they're both down. And then, like I said over here, when it was odd, you had opposites. You had opposite sides. All right. Final example, negative leading coefficient again. So we're going to be going in the down direction. That's how we're going to finish this graph. And then my degree of being 3 is an odd number, meaning there have to be opposites. So we're going to start in the opposite direction. So up and down. So you can memorize this table, or you can use little tricks. I always, this tells you how your graph is going to end on the right-hand side. And then your degree, I remember it tells me my other side will match because it's the same, or the other side will be opposite because it's odd. Okay, so do what works best for you. We're going to put it all together here. We're going to put them in standard form. We're going to classify, and we're going to identify end behavior and do how many turns this graph could have. Okay, so look in here. This is not in standard form. I got to have my highest exponent first, which is my cubed. So 3p cubed. Then we're going to go to my next highest degree, which is 2p squared, and then finish it with negative 4p. So the signs in front come with them. All right, from here, I see that my leading term, I have a exponent of 3, so that means it is a cubic. I see it has 3 different pieces, so that means it is a trinomial. It is a cubic trinomial. All right, so I classified it. My end behavior, okay, so my degree was 3. I know it's going to be opposite. And my leading coefficient is a positive 3. So I know it's going to end up in the positive direction. But my degree of 3 means my other side is going to be opposite. So this end behavior is going to be down and then up. Okay. And then how many terms are we going to have? Well, since I had a degree of 3, that means we can have a maximum of 2 terms in our graph. All right, number 2. We are not in standard form again. I see degrees 3, 2, 5, 3, and 2. All right, so we know 5 is my highest. That's going to come first. Negative comes with it. So negative 3, c to the 5th. Then I see 2 of them with a c of 3, so I'm going to put those next. 5c3 plus 2c3. And then I have 2 pieces minus c squared and plus c squared. This one is special, guys. I see some like terms going on. So negative 3c to the 5th stays, but look, 5c cubed and 2c cubed are like terms. I'm going to combine them to give me 7c cubed. And then here, negative c squared plus c squared, well, those cancel out completely. So our standard form is actually just going to be negative 3c to the 5th plus 7c cubed. All right, so highest degree is a 5. This is called a quintic. And I see that I have 2 different pieces, so this is a quintic binomial. All right. Our end behavior, it is a degree of 5. So again, it's going to be opposite directions, okay? And since my leading coefficient is a negative, it's going to end up in the negative. So it finishes in the negative direction. Degree of 5 tells me it's going to start in the opposite direction. So this is going to be up and then down. And then how many turns it can have, since it's a degree of 5, we're going to have 4 maximum number of turns to get there. Like that, something like that. Okay, you don't have to sketch a graph. I just do it because I'm very visual and it helps me out. You need to be referring to this chart, and this chart over and over and over again to help you out. All right, moving on. We're going to go to synthetic division. So here, to remind you of synthetic division, you write out all the coefficients after you have put it in standard form. If something's missing, we put a 0, and I'll show you an example of that here in a minute. Once that happens, you solve for the number that's going to go on the ledge, or in my class, we called it the magic box, okay? So whatever you're dividing by, that binomial, set equal to 0 and solve for x, and that's the number you get to put in there. I will show you how to divide by synthetic division. You bring your first number down. There's a multiply, add, repeat situation. I called it basketball. And then we're going to write our new equation using our new coefficients. Since we did divide, our answer will be 1 degree less than what we started with. Okay, so I'm going to show you an example here. 6x cubed minus 19x squared plus x plus 6. All right, this is already in standard form, so we're good to go. Okay, so step 1 told me to write out the coefficients. So we have the coefficients of 6. We have negative 19. There's technically a 1 right here. And then we have a positive 6. All right, but solve for the number on the ledge. So that's this piece right here. X minus 3 equals 0. So to get x by itself, we get x equals positive 3. That's what's going to go on the ledge or in the magic box, whatever your teacher uses. To divide, we always drop down the first number. And then we do basketball. So we're going to drop down this first number. So 3, and when we drop it down, we multiply. So 3 times 6 equals, that's going to give me a positive 18. Always put the positive or negative with it, because now negative 19, we're going to go bring it down again. Negative 19 plus 18 gives me a negative 1. Okay. We're going to do the same thing again. So I'm going to take my 3. This time we're going to bounce down to a negative 1. Bring that back up. 3 times negative 1 is negative 3. 1 minus 3. We're doing the same thing again. 1 minus 3 gives me a negative 2. Looks like we are going to basketball one more time. So 3 times negative 2 is going to give me negative 6. 6 minus 6 gives me 0. Now, the last number is always our remainder. So this has a remainder of 0. So I've done the work. Now I have to write the actual quotient. So when you divide, we get another polynomial. Started off with an x cubed, so our answer is going to start with an x squared. So we have 6x squared minus 1x, it's going to go in order, and then minus 2. Remainder is 0, so that is our quotient for this problem. All right, got 2 more. This one looks different, but it's asking you the exact same thing. So x to the 4th minus 2x cubed plus 13x minus 6. All right, first thing, it is in standard form. I'm going to put my coefficients down. Notice my degrees here, 4, 3. I don't see an x squared anywhere, then x, and then negative 6. So that means when I write my coefficients down, so I'm going to have 1 for x to the 4th, negative 2 for x cubed. There is nothing for x squared, so we got to put a 0. There's a 13 for my x, and then a negative 6 for my constant on the end. All right, the number that goes on the ledge or in my magic box comes from what we're dividing by. X plus 2, make that equal to 0. So here we see x equals negative 2. That's what goes in our box. Now time for synthetic division. So we've done the setup. Now let's do the work. All right, we're going to basketball. Negative 2 times 1 is going to give me negative 2. Negative 2 minus 2 gives me negative 4. Again, it's really important to bring the signs up with it. Okay. All right, now I have negative 2 times negative 4. That gives me a positive 8. So I am going to write the positive because now I'm going to add. 0 plus 8 gives me 8. All right. All right, basketball again, or bounce. Negative 2 times 8 is going to give us negative 16. 13 minus 16 is negative 3. One more bounce for this one. So we have negative 2 times negative 3, which is going to give us a positive 6. Negative 6 plus 6 gives me 0. Again, the final number is always our remainder. All right, so my new coefficients are 1, negative 4, 8, and negative 3. Started off with an x to the 4th, so that means my answer starts with an x cubed, and we go down in order. So we're going to have x cubed minus 4x squared. Sorry, guys. It's going to be a positive 8x and then minus 3. And that is our quotient. All right. I am going to show you what we need to do if we do get a remainder, and that's going to happen in this next one for us. We have 4x squared plus 23x minus 16 divided by x plus 5. So coefficients, we have standard form here, x squared, x, and a constant, so we're good. We're not missing anything. Coefficients are going to be 4, 23, and negative 16. Our number in the ledge or the magic box is going to be, make this equal to 0. So that gives me x equals negative 5. So we have negative 5 right here. Drop down our first number, which is a 4. And we start to multiply. So negative 5 times 4 is going to give us negative 20. 23 minus 20 is a positive 3. Multiply again to bring it back up. We have negative 5 times 3 is going to give us negative 15. Making sure I did all my stuff right. 4. Yeah, I'm good. Okay. When I subtract here, that gives me what? Negative 31. All right. That is our remainder this time. So my remainder is no longer 0. So when I write my answer here, again, it was x squared. My answer starts with just an x now. So it will be 4x plus 3, but the remainder of negative 31 was not divided evenly into x plus 5, okay? So that is still going to be over x plus 5. That's how we write our remainder. So 4x plus 3 plus the remainder of negative 31 over x plus 5. Or if you really want to, you can just say minus and then 31 over x plus 5. Technically, it is the same thing. So whichever one you like, take your pick. Okay? All right, so our next thing we're going to do in our notes is we're going to actually work backwards. So I'm going to give you some roots, and you're going to give me the function that it originated from. So like when we were solving quadratics or equations with factoring and all those good things, we were going the other way. Now I've given you the roots. I want you to give me the equation. Okay, so how do we do that? Well, we got to work the whole thing backwards. So here we have x equals negative 1. We have x equals 3. And we have x equals 1/2. Right now, I see there are 3 different roots. So I know that the polynomial this came from had to be an x cubed. Okay, so I'm going to keep working until I get me an x cubed. Okay, it's going to have to be x cubed something else. All right, bring each of these roots back with the x to make the factor. So I'm going to add 1 back to the x to move it over. So that factor is x plus 1. Subtract 3 over to make it back with its x, to make that factor x minus 3. And then here we're going to subtract 1/2 back over to make that factor x minus 1/2. Here we get to multiply. I'm going to multiply these first 2 together first by doing FOIL. So I'm going to FOIL these together. I'm going to get x squared minus 3x plus 1x minus 3, which is x squared minus 2x minus 3. And I still have to multiply it to x minus 1/2. All right. Multiply these together. You can do distribution. I personally like to use the box to help multiplying with these kinds of things. That's what I'm going to do over here. We have x. We have negative 1/2 multiplied by x squared minus 2x and then minus 3. Multiply. Here we're going to get x cubed, then negative 2x squared, then minus 3x. Down here, I'm going to have negative 1/2 x squared. Negative 2 times negative 1/2 is actually a positive 1, so that leaves me with just 1x. And then here, negative 1/2 times negative 3 is going to give me a positive 3 over 2. Okay, so we have x cubed. I see 2 things with an x squared, so I have to actually add or subtract these. So negative 1/2 minus 2 is going to give me negative 2.5, which is the same thing as saying negative 5 over 2. So minus 5 over 2 x squared. And then I also see there's 2 x's here. So that's going to be a 1 minus 3. So that's negative 2 x. And then we still have that positive 3/2 on the end. And that's the polynomial that it came from. I know y'all see fractions and you get scared, but you got to be able to work with it, okay? If you really wanted to change all these to decimals, you could. So that would be x cubed minus 2.5 x squared minus 2x, and that would be what, plus 2.5? That's the same thing if you wanted to make it into decimals. All right, let's do another one like this. Here we have x equals negative 3, 0, 0, and 5. So I'm going to write them out separately. I have x equals negative 3, x equals 0, x equals 0 again, and x equals 5. All right, I see 4 roots. So my degree of my polynomial is going to be a 4. Okay? Bring each of my roots back over with the x to make their factors. So here I'm going to add 3 back over. This factor is x plus 3. add or subtract the 0 back over, this is just going to be an x. X plus 0 is x. X plus 0 is x. Here, to move my 5 across the equal sign, I'm going to subtract it. So this factor becomes x minus 5. All right, we have 4 factors. We got to multiply them all together. I'm going to bring these two together first. That is x squared. Still have x plus 3 and x minus 5. I'm going to FOIL those two together. I'm going to FOIL those two together. That's going to give me x squared minus 5x plus 3x and then minus 15. So we have x squared, what is that, minus 2x minus 15. And it is still being multiplied by the x squared out front. So again, I know I'm not done because we're looking for a polynomial with a degree of 4. So I'm almost there. I'm going to multiply x squared, or distribute x squared through everything. So x squared times x squared is x to the 4th. Then we have negative 2. That'll be x cubed, because technically there's a 1 right here. And then that ends up with a negative 15x squared. So there's my x to the 4th, like I knew I was going to have. All right, one more of these. All right, write a polynomial function in standard form with the given zeros. Look at them now. They are both a square root. So here I have x equals the square root of 2, and I have x equals the negative square root of 2. All right, I still see 2 roots, so I know I'm going to have an x squared as my polynomial. Okay, that'll be my leading degree. From here, bring my roots back to my x's to make my factors. So I'm going to subtract x squared. So that's, square root of 2. This becomes x minus the square root of 2. Here I'm going to add it back over, so it becomes x plus the square root of 2. All right, same thing. Don't be scared of the square root. Work through it the same way. Now that I have my 2 factors, I'm going to multiply. In this case, I can do FOIL. X times x will give me x squared. X times the square root of 2 is going to be plus x square root 2. Negative square root 2 times x is going to be negative x square root 2. And then finally, negative square root 2 times the square root of 2, well, it's negative on the outside. 2 times 2, that gives me the square root of 4. All right, x square root 2 minus x square root 2, these are going to cancel out. So I have x squared, and look at this, square root of 4, we know that. Square root of 4 is going to be 2. So this becomes x squared minus 2. Makes sense, doesn't it? Weren't those conjugates in the beginning? So if you remember multiplying conjugates, your middle term will disappear like it did for us. All right, last section of notes. Okay, so that's kind of like in 3 parts. So here's our final part. So we had the naming, then we went into synthetic division and working backwards. Our final piece of the puzzle is going to be the rational root theorem. Okay, why is this important? Well, if I give you an equation, I want you to find the possible places, the roots, where it's going to cross the x-axis. Instead of going from an infinite number list to choose from, okay, that might happen, we can narrow that list, okay, to find potential roots of a polynomial. Doing that, we're going to take the leading coefficient, which is the very first number attached to our highest degree, and the constant, which is at the very end. And we're going to find the factors of each. So we'll do all the factors of the constant terms, so that's just the number on the end, and divide each of those values by all of the factors of the leading coefficient. And remember, we are doing the positive and negative of each. Okay? Examples. Here we go. List all the possible rational roots of the polynomial 3x squared plus 5x plus 2. All right, well, my constant comes first, so I need to find all of the factors of 2. Well, what times what could be 2? Well, it could be 1 and 2, right? So we're going to do positive and negative 1. positive and negative 2. Think about it. Why do we do positive and negative? Because positive 1 times negative 2, positive 1 times positive 2 gives me positive 2, and negative 1 times negative 2 gives me positive 2. All right, that's why we list both. Divide by the factors of my leading coefficient, which in this case is 3. What times what is 3? 1 and 3. And we have to include the positive and negative of each. Okay, that is the setup. Now we have to actually divide. So we're going to divide 1 by 1 and 3. Then we're going to divide 2 by 1 and 3. So 1 divided by 1. Again, we're going to have positive, negative, everything. I'm going to move this down here. So we're going to have positive and negative 1 divided by 1. Then we're going to have positive and negative 1 divided by 3, which stays 1/3. Now we're going to move on to 2. So 2 divided by 1 is positive and negative 2. And then we're going to finish it with positive and negative 2 divided by 3. These are all the possible places that this polynomial could cross the x-axis. Okay, and we're going to use that in a second. One more. All right, all of the factors of 3. I know it's negative 3. I don't care because we're using positive and negative of everything anyway. So the sign in front really does not matter right now. What times what is 3? Well, it is positive, negative 1, positive, and negative 3. Divide that by all of our factors of our leading coefficient in the very front, which is 2. So what times what is 2? Well, 1 times 2 is, can't forget positive and negative. All right, let's do our division. Again, we've done the setup. Now let's actually divide. So we have 1 divided by 1, 1 divided by 2, which will stay 1/2. All right, now I'm going to move on. 3 divided by 1 is just 3. 3 divided by 2 is going to be 3/2. Those are all the possible x values that polynomial could cross over. All right, why are we doing this? Well, because that's going to be the first step in finding all rational roots in polynomials. Usually we just factor or slip and slide or something like that. The issue is these aren't going to be quadratics, and all of those strategies are for quadratics. But now I have x cubed and x fourth, and it's going to be larger degrees, so we have to go this way. All right, so step 1, we're going to make our list of where it could happen. Step 2, there's 2 ways you can do it. You can first you can start plugging values into your equation until one of them makes your equation equals to 0. That's how you know you found an x-intercept. Or you can use Desmos or any other free graphing calculator app to find one of the places where the graph crosses the x-axis, which is a root, and then use that value for number 3, which is we're going to factor we're going to do synthetic division, and then we're going to use factoring to get any other roots. All right, so we got 2 examples of these, and then we're done. I know it's a long video. This was a whole lot of information this week. All right, here we go. We have 15x cubed minus 32x squared plus 3x plus 2. So first we have to find where this is crossing an x-axis, okay? Let's make our list first. So my list is going to be all of my factors of 2, which are positive and negative, 2 and 1? I'm going to do 1 first. So we know 1 times 2 divided by all of the factors of 15. Okay, so what can be divided into 15? Well, we have 1 and 15, and we have 3 and 5. Sorry, that's kind of crunched. So we have 1, 15, we have 3, and we have 5. All right, so that list is going to be all the division. So 1 divided by 1, 1 divided by 15, 1 divided by 3, and 1 divided by 5. Do it again, divide by 2. So we have 2 divided by 1, 2 divided by 15, 2 divided by 3, and 2 divided by 5. These are 1, 2, 3, 4, 5, 6, 7, 8. It's actually 16 because we have positive and negative. 16 possible places where this could be crossing the x-axis. Okay? Now, find one that works. You could plug and chug. You could plug in 1 into this equation. Does it equal 0? Plug negative 1 into the equation. Does it equal 0? Plug positive 1 over 15 in. You can test all of these, okay? It is possible if you don't have a calculator. Is it time consuming? Sure. I would suggest probably starting with your whole numbers and going from there. If you have a calculator, Desmos is free for anybody. So I'm going to pull that up on the screen for you. I'm going to type in our equation. So we have 15x cubed minus 32x squared plus 3x and then plus 2. So when I type that in, it shows me it shows me actually where it does cross over. It looks like we have a decimal, so it's negative 0.2, positive 0.3, and then we have 2, 0. I like that 2, 0. I'm going to use 2 for my next step. So here you're finding one of the roots. We know all 3 of them, but we have to use one to prove that the others actually exist. So I'm going to pick one of these. I like whole numbers. I'm going to pick 2. So I'm going to choose 2 first. How am I going to use it? That's what's going to go on my ledge or my magic box for synthetic division. So we have 15. I'm doing my coefficients now. 3, 2, 1. There we go. We're going to use this to find our other roots. We know what they are. I know from this it's negative 0.2 and 0.33. This is showing my work and proving that those are actually my other roots. So drop 15. Synthetic division, 2 times 15 is positive 30. Add these together, we get negative 2. 2 times negative 2 is negative 4. Subtract this time. 3 minus 4 is going to give me negative 1. 2 minus 1, negative 2. Look at that. So I have also proven here that it's going to be a root because my remainder was 0. Now we have to take 15x squared minus 2x minus 1, and we have to factor this. Lots of ways to do it. I am personally going to do slip and slide. So I'm going to bring my 15 over here. We have x squared minus 2x minus 15. I'm going to factor this to get me what? X minus 5 and x plus 3. Don't forget to slide the 15 back out. 5 over 15 simplifies to, what is that? 1 over 3. So we have x minus 1 over 3. And here 3 over 15 simplifies to 1/5. And I can actually solve for x in each of these. So this will give me x equals 1/3. And this will give me x equals, what is that, negative 1/5. Okay. So after you solve it however you want to, we have to write out all of the roots. Okay. Since my original equation was an x cubed, I know I'm going to have 3 answers. Those 3 answers are x equals, the first root we found from our graph is 2, and then the other 2 roots that we found from dividing and factoring. So 2, 1/3, and, negative 1/5. Or 2.3 and negative 0.2, which we did see in our graph. All right. Okay. Last one. Almost there. I know this is long, guys. Here we go. 8x cubed plus 2x squared minus 5x plus 1. List all my roots. All right. Well, all the factors of 1. Well, that's nice. It's just positive and negative 1. We're going to divide that by all of my factors of 8, which is going to be what? 1 and 8. What else can do it? 2 and 4. Okay. Oh my gosh. Here we go. So Let's make this list. So we have positive and negative 1 divided by 1. We're going to have positive and negative 1 divided by 8. We have positive and negative 1 divided by 2. And we have positive and negative 1 divided by 4. So technically I have 1, 2, 3, 4, 5, 6, 7, 8 places that could cross our x-axis. You can use your calculator or again plug and chug, start plugging numbers in. Again, I would suggest starting with the whole numbers. So find one that when you plug it in, it gives you 0, or your graphing calculator if you want to plug it in there. Let me show you what I'm doing here. Oh, hold on. So on this, you actually plug in your equation on the side. So I'm going to do 8x raise it to the power of 3 plus 2x squared minus 5x and then plus 1. All right, and it does show me the graph. I see there are 3 spots, which there should be. They're very little. So I know it's going to be, oops, sorry, we had -1, 0.25, and 0.5. So I know my 3 roots. Again, I'm not done. I have to prove it. So pick one of these first for synthetic division. I'm going to pick -1 because it's a nice whole number. Okay, that is also part of the list that I made. -1 is there. So I'm going to choose -1 to plug in my ledge. My polynomial is not missing anything, so drop down my coefficients. And we're going to do synthetic division. Drop that one down. -1 times 8 is -8. 2 minus 8 is -6. Multiply again. -1 times -6 is +6. Add these together to get me a +1. -1 times 1 is -1. 1 minus 1 is 0. That better happen because I just saw that it was an actual x-intercept. And that mathematically proves that it's an x-intercept. Okay? Take my new equation, which is going to be 8x squared. Remember, it drops down an exponent. Minus 6x and then plus 1. All right, I'm going to solve this one. I'm going to do slip and slide again. So I'm going to slip the 8 to the end. We have x squared minus 6x plus 8 equals 0. That becomes what? X minus 4 and x minus 2. Slide that 8 back out. This fraction will simplify to x minus, that's 1/2. This simplifies to x minus 1/4. Solve for x, going to add that out. So x equals a positive 1/2. Add that out. Here we have x equals positive 1/4. So 1/2 and 1/4. Still not done. That was all the work. Let's get my roots. So we have 3 of them. We have x equals the first one we used for synthetic division. Then we have the other 2 that we got after we factored. So 1/2 and 1/4. Okay. And if you notice, that is what we saw on our graph. 0.25 is 1/4, 0.5 is 1/2. All right, and then that is our answer. So the most common mistake here is that people forget the first solution that they used is part of their roots. Okay, long video, lots to do. If you have questions, reach out. Due by Friday. Good luck.